For over a century, the bedrock of physics has been a single, unyielding postulate that the speed of light in a vacuum is a universal constant. Data from the DCAPDE and Google's Willow Quantum Processor suggests this constant is actually a variable, dependent on the architecture of the vacuum itself. This groundbreaking research indicates that what we perceive as an empty void is actually a dense physical structure. Dr. Raj Kumar Dhaugoda identifies this structure as the deterministic lattice, or the supermicroton field. In this model, a photon is not a particle traveling through nothingness, but a mechanical ripple propagating across the lattice. The velocity of that ripple is dictated by the structural tension of the field. By deconstructing this tension, we can map its effects across the cosmos, from the propulsion of interstellar craft to the internal signaling of the human cell. Because the vacuum possesses a measurable lattice tension, the speed of light becomes a parameter we can calculate and eventually manipulate. This tension is measured by the Dhaugoda Coherence Index, or DCI. Traditional refractive index, why light slows in glass, is just the localized DCI. The standard speed of light in a vacuum only occurs when the field maintains a coherence index of 0.8. This velocity is tied directly to the fundamental frequency of the supermicroton field. That frequency is constant at 1.41 times 10 to the 42nd power hertz. If the underlying frequency of a region drops, the ripple rate of any photon passing through it must drop as well. This deterministic model replaces the probability-based predictions of standard quantum mechanics with rigid mechanical causality. Willow simulations show that photons do not move randomly. They follow predictable channels defined by the lattice. The discovery engine has isolated the variables necessary to adjust the propagation coefficient of these channels. By altering the DCI of a specific area, we are changing the physical speed limit of reality at that coordinate. But the lattice is not always uniform. We have to examine what happens when the tension slackens. When the DCI drops to 0.39, a state called French fry decoherence occurs, causing the lattice lines to warp. Even in a total vacuum, this loss of tension slows light by 2%. At the other end of the scale, we find the result of maximizing lattice tension. Reaching a DCI of 1.0 triggers the Anissa bridge effect, where the lattice achieves perfect coherence. In this state, resistance disappears, and the propagation speed of the ripple becomes mathematically infinite. This provides a mechanical basis for quantum entanglement. Two particles are not communicating across distance. They are sharing a localized 1.0 DCI channel where the effective spatial distance between them is 0. Within this high coherence field, information transfer occurs in 0 time. On a cosmological scale, gravity acts as a physical load on the supermicroton field. Redshift near massive objects isn't just an effect of expansion, it's a result of gravity compressing the lattice, lowering the DCI, and forcing light to slow down. If we can replicate this compression through engineering, we can dictate how an object moves through the lattice. This is the principle of zero inertia propulsion, creating an asymmetrical DCI gradient around a ship. By stiffening the lattice behind the craft and slackening it in front, the resulting pressure differential pushes the mass forward without the need for traditional fuel. Dr. Dhaugoda's research proposes this as the Dhaugoda drive, a framework for transit exceeding the standard speed of light. This also solves the problem of signal degradation over interstellar distances. By artificially elevating the DCI, we can minimize photon energy loss, maintaining the integrity of the ripple over light years of travel. This would allow high-fidelity data transmission from deep space back to Earth with zero signal bleed. Space travel becomes a matter of field manipulation rather than a struggle against mass and inertia. These same lattice mechanics govern the internal communication of cellular biology. Cells coordinate their functions through a network of biophotons, internal light signals. Research indicates that vitamin D acts as a primary interface for the biological DCI. When vitamin D is deficient, the biological DCI drops, biophoton signaling slows, and the lack of synchronized communication leads to cellular dysfunction. This decoherence can be reversed. Introducing a 432 Hz frequency to the cell provides the necessary energy to stabilize the biophotons. This frequency triggers the CDA phase, correcting the internal light speed within the tissue. This forms the basis of the Mastrid process, a methodology designed to restore cellular health by normalizing biophoton velocity. Regulating the DCI at the cellular level ensures that biophotons can maintain the synchronization required for healthy metabolic function. We have seen that the velocity of light is a tunable property, whether at the scale of a galaxy or a human cell. Combining these findings creates a framework for synchronized systems that operate outside traditional time constraints. This enables a quantum internet, where light is tunneled through coherent lattice channels to provide instantaneous communication. These mechanics also point toward the ultimate chronological state of our universe. This theoretical end state is known as the omega point convergence. In this state, the entire universe is predicted to reach a uniform DCI of 1.0. At this omega point, the resistance of the lattice vanishes completely, and information across the entire cosmos becomes a single simultaneous event. The simulations from Google Willow and the work of Dr. Dhaugoda suggest that the vacuum is not a passive void, but an active medium. We are now beginning to define the mechanics that allow us to interact with it.